Right. So as we're saying, what happens in non-cyclic photophosphorylation? So सबसे पहले we have both PS2 and PS1. दोनों के ऊपर we have light falling in. तो ये है आपका क्वांटोसोम thylakoid and you have outer membrane with PS1 and inner membrane with PS2 और दोनों के ऊपर photons are there. Photons come with energy. So photons come with energy on both PS2 and PS1. And photons may energy gets absorbed. If you remember, PS2 may who will do absorption? Chlorophyll A 670 and lots of chlorophyll B, carotenes and xanthophylls, 50 of them. And by resonance transfer, they will transfer energy to chlorophyll A 680. And chlorophyll A 680 at 680 nanometer wavelength of light will jump. The electron will jump and chlorophyll A 680 will become ionized. Chlorophyll A 680 of PS2 will lose electron at 680 nanometer wavelength and electron will jump and chlorophyll A 680 will become ionized. Chlorophyll A 680 बाकी PS1 के अंदर which were the accessory pigment? Chlorophyll A 683, 200 of them. Few chlorophyll B, 50 carotenes and xanthophylls, and they will by resonance transfer the energy to chlorophyll A 700. And not at 680 but at 700 nanometer wavelength the electron will jump and chlorophyll A 700 will become ionized. Now who will get ionized first, PS2 or PS1? If you remember, PS2 chlorophyll A 680 at 680 nanometer wavelength will get excited and electron निकल जाएगा. And for 20 nanometer wavelength more means for a fraction of a millisecond later at chlorophyll A 700 at 700 nanometer wavelength will lose electron and will get ionized. So effectively PS2 also releases electron at 680 nanometer wavelength. PS1 also on receiving light loses electron at 700 nanometer wavelength. And where will these electrons go? From PS2, the electron will go to Q. Q is called quinone. And from PS1, the electron will go to Z. If you remember, FRS, ferredoxine reducing substance. From quinone, the electron goes to plastoquinone. So quinone it goes to plastoquinone, then to cytochrome B6, then to cytochrome F. So where has the electron gone from? PS2, the electron has gone to quinone, from quinone to plastoquinone, to cytochrome B6, to cytochrome F. Now 680 nanometer pe PS2 has lost its electron, and ye electron while it is passing from quinone to plastoquinone to cytochrome B6 to cytochrome F to plastocyanine in the meantime PS1 at 700 nanometer has also lost its electron to Z. So अगर हम ये प्रोसेस को पॉज कर ले, पॉज, pause कर ले, PS2 is also in an excited state. PS1 is also in an excited state. Where has electron from PS2 gone towards plastocyanine? And where has electron from PS1 gone to Z? तो अगर ये प्रोसेस, ये तो कंटिन्यूस प्रोसेस है, बहुत फास्ट हो रहा है, लेकिन हम इसको पॉज कर लेते हैं, पॉज। तो PS2 का इलेक्ट्रॉन किसके पास है? प्लास्टोसियानिन के पास। PS2 का इलेक्ट्रॉन प्लास्टोसियानिन के पास है और PS1 का इलेक्ट्रॉन Z के पास है। सो PS2 electron is with plastocyanine and PS1 electron is with Z. Now pause को वापस प्ले करते हैं, प्ले वापस करते हैं। Now from plastocyanine electron can go to PS2 because PS2 is excited and ionized So it is P680 plus. It has lost its electron, and PS1 is also ionized. It is P700 plus, not P700, P700 plus, because it has lost its electron. So from plastocyanine, the electron can go to PS2 also, क्योंकि वो भी ionized है, to PS1 also, क्योंकि वो भी ionized है. But electron जाता किसके पास है? Electron goes from plastocyanine to PS1 because PS1 has got greater electronegativity compared to PS2. In other words, PS1 is more electronegative, has got a greater redox potential compared to PS1. So electron goes from plastocyanine not to PS1 but to not to PS2 but to PS1. And PS1 gets the electron from plastocyanine, and plastocyanine donates the electron to PS1 and brings PS1 into a ground state. So where has the electron gone from? Electron has gone from PS2 to PS1. So this is a non-cyclic process. And PS1 का electron had gone to Z. From Z, it goes to ferridoxine. Now from ferridoxine, it is supposed to go to cytochrome B6, cytochrome F, plastocyanine, and return back to PS1 like cyclic. But PS1 के पास तो electron already आ चुका है PS2 का. And PS1 तो already has gone back into a ground state. तो PS1 का इलेक्ट्रॉन खुद के पास तो नहीं आएगा क्योंकि PS2 का इलेक्ट्रॉन PS1 के पास आ चुका है. तो PS1 का इलेक्ट्रॉन जाएगा किधर? PS1 का इलेक्ट्रॉन went to Z. Z से it went to ferridoxine, and ferridoxine से electron is accepted by NADP, nicotinamide adenine dinucleotide phosphate, accepts the electron and retains the electron. So electron is retained by NADP. So this process is completely non-cyclic. Where has electron gone from? From PS2, the electron has gone to PS1. And from PS1, the electron has gone to NADP. And NADP has retained the electron. So this is a non-cyclic process. Now PS2 lost the electron, PS1 lost the electron. PS2 इलेक्ट्रॉन रिटर्न्स बैक टू PS1 और PS1 तो ग्राउंड स्टेट में आ सकता है, बट याद है क्लोरोफिल A cannot remain in an ionized state for more than 10 raised to minus 9 seconds. So PS2, in other words, chlorophyll A 680 plus has to immediately come back to a ground state in less than 10 raised to minus 9 seconds. तो ये कैसे पॉसिबल होगा? PS1 का इलेक्ट्रॉन NADP के पास चला गया, PS2 का इलेक्ट्रॉन PS1 के पास चला गया, तो PS1 तो लॉस्ट इलेक्ट्रॉन बट गेन्ड इलेक्ट्रॉन मींस इट हैज कम बैक टू ग्राउंड स्टेट, वो ग्राउंड स्टेट में आ गया है in less than 10 raised to minus 9 seconds. PS2 has lost its electron. Who will bring it to ground state? Light induces breakdown of water. H2O splits, and H2O splits to form H plus proton and OH minus electron. So proton and electron or OH minus hydroxyl. So H plus and OH minus. Of OH minus, the electron goes from OH minus back to PS2 and brings PS2 back to a ground state. So water ka breakdown, which is called photolysis. Lysis breakdown in the presence of photon, light. Photolysis of water takes place and H2O splits to form OH minus and H plus. OH minus gives away the electron to PS2, brings PS2 back to ground state, and OH minus, hydroxyl ion, becomes hydroxyl OH, and electron returns to PS2, brings it back into a ground state. So where has the flow of electrons been? Nice logic. Electron has gone from water to PS2, from water to PS2, from PS2 electron has gone to PS1, and from PS1 the electron has gone to NADP. Pura process non-cyclic. Once again, where has electron gone from? Water electron has gone to PS2, PS2 electron has gone to PS1, and PS1 electron has gone to NADP, which has retained the electron. This was called one non-cyclic process. And NADP minus, this is NADP with electron. Is it energy with energy or without energy? If you remember, NADP minus has a lot of energy because it has got electron which was given away by excitation of PS1. तो बहुत सारी solar energy trapped है. So NADP minus has got electron with lot of energy, and PS2 also liberated electron with a lot of energy. It went to quinone, it went to plastoquinone and dissipated energy. Plastoquinone says cytochrome B6, it dissipated energy, but PS2 में थोड़ी एनर्जी कम है कंपेयर टू PS1. तो इसीलिए इलेक्ट्रॉन एक्सेप्टर वाज नॉट Z, इट वाज क्विनोन. क्विनोन के बाद इट वेंट टू प्लास्टोक्विनोन. हाँ, प्लास्टोक्विनोन से इट वेंट टू साइटोक्रोम B6, देन टू साइटोक्रोम F, देन टू प्लास्टोसियानिन. ये तीन साइटोक्रोम सेम है. साइटोक्रोम B6, साइटोक्रोम F, प्लास्टोसियानिन. ये साइक्लिक जैसे ही है. And during transfer of electron from cytochrome B6 to cytochrome F, energy was dissipated that combined with ADP and IP to form a molecule of ATP. So non-cyclic photophosphorylation में भी energy ATP बनता है from transfer of electron from PS2 to PS1. We have one ATP produced. एक ATP बनता है from PS2 to PS1 during transfer of electron from cytochrome B6 to cytochrome F. एक ATP बनता है. Cyclic में, if you remember, between ferredoxine, cytochrome B6, one ATP, between cytochrome B6, cytochrome F, another ATP. So cyclic process में दो ATP बनते हैं, लेकिन non-cyclic process में because PS2 is only with 680 nanometer wavelength, थोड़ी कम energy है, तो it went to quinone, then to plastoquinone, उसमें ATP नहीं बनता है. But from cytochrome B6 to cytochrome F, 7.3 kilocalorie liberate होता है और एक ATP बनता है and it goes to plastocyanine and back to PS1. So one ATP is formed between cytochrome B6 and cytochrome F. So there is ATP. And NADP minus is with electron with a lot of energy. And this was one non-cyclic process. This process repeats again. तो और एक बार ये प्रोसेस रिलीज होता है, तो वापस लाइट गिरती है and PS2 liberates one more electron. So now say two electrons are accepted by quinone and two electrons are given by quinone to plastoquinone. From plastoquinone, two electrons are given to cytochrome B6. That means 2 ADP plus 2 IP become 2 ADP. And 2 electrons are given by cytochrome F to plastocyanine. 2 electrons by plastocyanine to PS1. 2 electrons are given by PS1 to Z. Z gives 2 electrons and 2 electrons are accepted by ferredoxine. So NADP accepts 2 electrons. So it will become NADP minus 2. So कितनी बार non-cyclic process हुआ? 2 बार. पहले non-cyclic में electron went from PS2 to PS1 to NADP and second time also PS2 to PS1 to NADP. So 2 electron टोटल कितने फोटॉन्स यूज किए हमने? PS1 के ऊपर एक फोटोन आया, PS2 के ऊपर एक फोटोन आया, PS1 के ऊपर एक फोटोन आया एंड उसमें एक नॉन साइक्लिक प्रोसेस हुआ. फिर PS2 के ऊपर और एक फोटोन आया, PS1 के ऊपर और एक फोटोन आया, तो टोटल 2 फोटोन प्लस 2 फोटोन 4 फोटॉन्स. उसमें 2 नॉन साइक्लिक प्रोसेस हुए. तो वंस अगेन PS2 1 फोटॉन, PS1 1 फोटॉन, 2 फोटॉन्स में PS2 to PS1 1 इलेक्ट्रॉन, PS1 to NADP अनदर इलेक्ट्रॉन. तो 2 फोटॉन में एक नॉन साइक्लिक प्रोसेस हुआ. तो वापस PS2 PS1 पे एक एक फोटॉन and PS2 to PS1, PS1 to NADP, in other words, 2 photons. So 2 plus 2 total 4 photons हो गए. 4 photons में 2 non-cyclic process हुए और 2 non-cyclic process में ध्यान से देखना यहाँ पर PS2 has now, I'll just show you, PS2 has now lost 2 electrons. And 2 electron went to quinone, which has given 2 electron. And cytochrome B6 से cytochrome F से plastocyanine से PS1 2 electron has gone to PS1. And how many ATPs are formed? 2. 2 electron from PS2 has gone to Z and NADP has accepted 2 electron to become NADP minus 2. NADP minus 2. Most importantly, photolysis of water will also take place twice. So 2H2O will split to form 2H plus and 2OH minus. 2OH minus will form 2OH and 2 electron will go to PS2. So ध्यान से दो नॉन साइक्लिक प्रोसेस में PS2 के ऊपर फोटोन एंड अनदर फोटोन, PS1 के ऊपर भी फोटोन एंड अनदर फोटोन. सो एक फोटोन PS2 पे, एक फोटोन PS1 पे, उससे हुआ एक नॉन साइक्लिक प्रोसेस. और दूसरा फोटोन आया PS2 पे, दूसरा फोटोन आया PS1 पे, तो उससे हुए दो नॉन साइक्लिक प्रोसेस. So how many photons are used? 4. PS2 one photon, PS2 another photon, 2 photons, 1 non-cyclic process. Again PS2 पे एक photon, PS1 पे एक photon, वापस से एक non-cyclic process. So 4 photons में 2 non-cyclic process होते हैं. 4 photons, 2 non-cyclic process. Golden word. How many ATPs are formed? 2. एक नॉन साइक्लिक में एक एटीपी बना, तो दो नॉन साइक्लिक में दो एटीपी बनेंगे. How many photolysis of water take place? 2. And 2H2O split to form 2OH minus and 2H plus. Golden word. 2H plus combined with NADP minus 2. And NADP minus 2 plus 2H form NADP minus 2 plus 2H plus form 2 form NADPH2. So once again, NADP minus 2 plus 2H plus form NADPH2. तो दो नॉन साइक्लिक प्रोसेस में से दो फोटोलाइसिस हुए, दो फोटोलाइसिस ऑफ वाटर से 2H प्लस लिबरेट हुए, और 2H प्लस एक NADP माइनस 2 के साथ कंबाइन होके बनता है NADPH2. NADPH2 बन गया. NADPH2. Sir, is NADPH2 a molecule with energy or without energy? It has a lot of energy because it involved 2 electrons from PS1. और PS1 तो याद है, कंपेयर टू PS2 जो 680 नैनोमीटर पे ही इलेक्ट्रॉन एक्साइट हुआ, PS1 का इलेक्ट्रॉन तो 700 नैनोमीटर पे एक्साइट हुआ था. यानी PS1 का इलेक्ट्रॉन हैज गॉट मोर एनर्जी compared to PS2 electron, and PS2 one ka electron went to Z, then to ferridoxy, and then to NADP minus 2. So NADP minus 2 has 2 electrons rich in energy, and NADP minus 2 with 2 electron rich in energy, when they combine with proton, NADP minus 2 is already rich in energy, combined with 2 proton to form NADPH2 is rich in energy. NADPH2 is rich in energy. And yay! NADPH2 energy rich है. तो आपके पास नॉन साइक्लिक प्रोसेस में दो मॉलिक्यूल हो गए जो एनर्जी रिच है। एक तो हो गया एटीपी जो एनर्जी रिच है, और दूसरा हो गया NADPH2 जो एनर्जी रिच है। एंड दोनों ATP plus NADPH2 are formed by the process called non-cyclic photophosphorylation। तो ATP और NADPH2 दोनों बनते हैं, साइक्लिक में ATP बनते हैं। And where are they formed? In the grana. And from grana, both ATP and NADPH2 will go in the stroma. And stroma में carbon dioxide will combine with water, and CO2 plus H2O will now combine with NADPH2 and ATP। एंड NADPH2 की सोलर एनर्जी और ATP की सोलर एनर्जी CO2 और H2O के साथ कंबाइन हो जाएगी टू फॉर्म C6H12O6, ग्लूकोज बनेगा। And that process is something called as the dark reaction. So there is ATP and NADPH2 formed in the grana, in which solar energy is converted into ATP and NADPH2, which are rich in energy. And both ATP and NADPH2 go from the grana into the stroma. And in the stroma, NADPH2 and ATP, which are both rich in solar energy, combine with CO2 and H2O and form energy rich molecule called as C6H12O6. ग्लूकोज इज फॉर्म। तो ग्लूकोज में कौन सी एनर्जी है? ग्लूकोज में है सोलर एनर्जी। ग्लूकोज में सनलाइट की एनर्जी है। हाँ, लेकिन CO2 और H2O डायरेक्टली सनलाइट को यूज नहीं कर सकते हैं। तो CO2 और H2O क्या यूज करते हैं? ATP एंड NADPH2, जो पहले ग्राना में बनते हैं बाय समथिंग कॉल्ड लाइट रिएक्शन। एंड लाइट रिएक्शन से ग्राना में ATP और NADPH2 एनर्जी रिच मॉलिक्यूल बनते हैं जिसमें सोलर एनर्जी ट्रैप्ड है। एंड फ्रॉम ग्राना both ATP and NADPH2 go into stroma, and stroma में CO2 and H2O combine with NADPH2 and ATP to form energy rich C6H12O6, और वो बन जाता है ग्लूकोज जो हम लोग खा सकते हैं। तो ग्लूकोज में कौन सी एनर्जी है? ATP और NADPH2 की एनर्जी, जो CO2 और H2O के साथ कंबाइन होकर ग्लूकोज बना। बाय द वे ATP NADPH2 आया किधर से? फ्रॉम PS2 एंड PS1, जिसमें सोलर एनर्जी थी। तो हम लोग क्या खा रहे हैं व्हेन वी आर ईटिंग ग्लूकोज? वी आर ईटिंग ATP एंड NADPH2। इन अदर वर्ड, वी आर ईटिंग सोलर एनर्जी। हम लोग सनलाइट खाते हैं, सनलाइट में से हमको ग्लूकोज मिलता है। ब्यूटीफुल प्रोसेस, करेंगे नेक्स्ट लेक्चर में। चलो, फॉर द मोमेंट वी हैव अंडरस्टूड दैट two non-cyclic processes have formed 2 ATP and 1 NADPH2. So two non-cyclic processes have formed 2 ATP and 1 NADPH2. How many photolysis took place? 2. How many photolysis took place 2, and 2H2O formed 2OH minus, जिसके अंदर से 2 electrons went to PS2, brought it back to ground state, and we have 2OH. तो 2 OH रह जाते हैं. How many non-cyclic process took place? 2. How many photons were used in this process? 4. First photon for PS2, second photon for PS1, 2 photons, 1 non-cyclic process. 2 photons, 1 non-cyclic process. So 4 photons, 2 non-cyclic process. And 2 non-cyclic process will produce 2 ATP, 1 NADPH2, and 2 photolysis of water. This process takes place 4 times. ध्यान से सुनना. This process takes place 4 times. So PS2 के ऊपर 4 photons गिरेंगे. PS1 के ऊपर 4 photons गिरेंगे. And PS2 will give out 4 electrons, which will pass through quinone, plastoquinone, cytochrome B6, cytochrome F, plastocyanine, and 4 electron will go to PS1. 4 electron from PS1 will go to Z, and 4 electron will go to ferridoxine. By the way, who will accept these electron? NADP. एक NADP ने कितना इलेक्ट्रॉन एक्सेप्ट किया? 2 इलेक्ट्रॉन. सो 4 इलेक्ट्रॉन को एक्सेप्ट करने के लिए वी हैव 2 NADP. 2 NADP will accept 4 electron and form 2 NADP minus minus. 2 NADP minus minus. तो उसमें 4 इलेक्ट्रॉन आ गए. And how many photolysis of water will take place? 4 photolysis of water to form 4H plus and 4OH minus. 2 NADP with 2 electron combined with 4 proton to form 2 NADPH2. 2 NADPH2. तो 2 NADPH2 बन जाते हैं. And 4OH minus will form 4 electron, which will bring PS2 back to ground state, और बच्चा 4OH. 4OH, 4 hydroxyls. तो ध्यान से, how many times non-cyclic process took place? 4 times. How many photons were involved? 4 photons in PS2, 4 photons in PS1. And how many ATPs were formed? 4 ATP. 4 ATP. How many NADPH2 are formed? 2 NADPH2. And how many photolysis of water took place? 4H2. उसमें से 4 electrons brought PS2 back to ground state. बचे 4 hydroxyl, 4OH form 2H2O and O2. Oxygen बनता है, which is liberated as free molecular gas. और ये एक free molecule oxygen liberate होके निकल जाता है. So 4 non-cyclic process के बाद, 4 photolysis of water के बाद, 4 OH minus से 4 OH and 4 OH form 2H2O and liberate 1 O2, which is liberated as free gas. So golden words. How many non-cyclic processes took place? 4 non-cyclic processes. And how many photons were used? 4 photons for PS2, 4 photons for PS1. In other words, 8 photons were used. How many ATPs were formed? 4 ATPs. How many NADPH2 are formed? 2 NADPH2. And how much oxygen is liberated? 1 oxygen is liberated. तो 4 non-cyclic process, golden words, 4 non-cyclic process. I'll show you in words. 4 non-cyclic photophosphorylations use 8 photons of light, splitting 4 water molecules, producing 2 NADPH2, 4 ATP, 2 H2O and 1 O2. 4 non-cyclic process use 4 photons plus 4 photons, 8 photons to produce and 4 photolysis of water to produce 4 ATP, 2 NADPH2, 2 H2O and liberate 1 oxygen molecule. तो कितने नॉन साइक्लिक प्रोसेस एक ऑक्सीजन मॉलिक्यूल के लिए? एक ऑक्सीजन मॉलिक्यूल के लिए 4 नॉन साइक्लिक प्रोसेसेस यूज होते हैं. 4 नॉन साइक्लिक प्रोसेस से एक ऑक्सीजन मॉलिक्यूल लिबरेट होता है. और एक ऑक्सीजन के साथ फोटोलाइसिस कितने हुए? 4. NADPH2 कितने बने? 2. ATP कितने बने? 4. और सबसे इंपॉर्टेंट, फोटॉन्स कितने यूटिलाइज हुए? 8 photons. For one non-cyclic process, we use 2 photons. One for PS2, one for PS1. So for 4 non-cyclic process, we use 4 photons for PS2, 4 photons for PS1. So a total of 8 photons of light are required. Beautiful. We end this entire process. Number of photons required to liberate 1 oxygen molecule is 8. 8 photons are required. 8 photons are required. 4 photon and 4 photon of PS2, PS1 for 4 non-cyclic process, and 4 non-cyclic process or 4 photolysis of water took place to liberate 1 oxygen molecule. So a total of 8 photons, 4 plus 4 and 4 non-cyclic processes and 4 photolysis of water to liberate 1 oxygen molecule. That is called as the quantum requirement. So what is quantum requirement? The number of photons required for liberating 1 oxygen molecule. तो एक ऑक्सीजन मॉलिक्यूल लिबरेट करने के लिए कितने नॉन साइक्लिक प्रोसेस हुए? 4. 4 नॉन साइक्लिक. And how many photons were required? 4 for PS2, 4 for PS1. A total of 8 photons were required for liberating 1 oxygen molecule, and that is called as quantum requirement. Chalo. Beautiful process. Cyclic and non-cyclic photophosphorylation, something called as light reaction. We have a very beautiful process called dark reaction, जो हम लोग next lecture में करेंगे, जिसमें carbon dioxide and water combined with NADPH2 and ATP. And ATP जो energy rich है and NADPH2 जो energy rich है. This energy rich ATP and NADPH2 will combine with CO2 and H2O to form energy rich molecule called C6H12O6 and ये होगा energy rich C6H12O6 and that process is something called as the dark reaction. उसे क्या कहते हैं? Dark reaction. So what was cyclic and non-cyclic photophosphorylation? Light reaction. Light reaction में what did we convert? Solar energy, sunlight into ATP and NADPH2, which are energy rich. And that is in grana. In the stroma, ATP and NADPH2 will combine with CO2 and H2O to form energy rich glucose, and that is called as the dark reaction. So, beautiful process. I hope you all have understood this. Take care, beta. God bless you. See ya.